Oh my goodness, we don't know how to use the squares, the periodic table? Well, let's look at these really quick. What I'm calling the square is this little square of information that we find on the table. Now, the one on your practice test is going to be uranium 238, but we're not going to use the same one that we're going to use on that test. We're going to let you figure that out. Now, this is going to be really easy to do. So let's first of all, let's go over number 3. We're going to find the atomic number. We're going to find the average mass. We're going to find out how many protons it has, how many electrons it has, and how many neutrons it has. And so from this, we'll go on to a different table. I chose, whoopsie, where's it at? I chose sodium. And boy, that's a big sodium, isn't it? Bigger than I thought. Okay, so I'm choosing sodium to use here, and the reason I'm using this is because it was convenient. Okay, so we know the name is sodium, that's right there. Let's look at this small number. Now, it doesn't always have to be on the top like this right here, but this small number, let's change the size of that font a little bit. Let's go with this. That small number is known as the atomic number. All right, and its atomic number tells us a few different things. The first thing it really does is it's the number of the element on the table. So that's why it's the atomic number. But that is also the same as the number of protons, right? Because that's how they're ordered, by the number of protons. So sodium has 11 protons. Now, if sodium is an atom, that means it's not an ion, it's not charged, then we also want to know how many electrons it has. And so the protons and electrons, since one's positive and one is negative, cancel each other out in a neutral atom. So the atomic number is also the number of electrons in a neutral atom. Okay, let's go look at this big number, this big scary number down here on the bottom, right? Well, that big number on the bottom is the mass. Right? And the mass is made up by the number of nucleons. Ooh, that's a scary word. No, nucleons just means things that are in the nucleus. And we know in the nucleus we have the protons and the neutrons. So the mass is equal to the number of protons and the number of neutrons. All right, so that's the mass. So we're going to round this. There's different isotopes. Isotopes means there's different number of neutrons and different elements. And this is an average so that the normal Joe like us, we don't have to worry about these radioactive isotopes or anything like that, because we're not going to deal with the nucleus. We're only dealing with the outer shells of these atoms. So they rounded these weights together for us. And so we're going to round that up to 23. So we're going to say the mass of that is 23. Well, there were 11 protons and how many neutrons? Oh my gosh, advanced algebra. 12 plus 11 equals 23, so we have 12 neutrons. So take the number of the mass, take the mass number, subtract it from the atomic number, and you get the number of neutrons, or also known as the neutron number. I hope that helps. Okay, now, the next question we're going to look at isn't the next one in line. We're going to look at question number 6. And the reason I'm doing number 6 is because it fits with what I have information-wise in front of me. So I don't have to get this table back out here in a second. And so it wants to know how many energy shells I have. Now, I'm going to pick sodium again because I have that huge block of sodium. Yeah, that's pretty funny. Okay, so let's look at sodium. All right, so first of all, we want to know how many shells it has. If you'll remember, as we counted down the side, ooh, my font looks huge now. We count down the side, we know the number of shells. Okay, so that was shells right there. Ooh, I can't see that. Come on, quit that. Okay. My critics are telling me I probably should change my font. There, so that's the number of shells. So what's sodium have? Sodium has 3 shells. Okay. Now, valence electrons. I was doing molybdenum before, but I didn't want to do that. So I changed it to a different video. Okay, we're going to look for the valence electrons. Now, valence electrons are the number of electrons in the shells. Remember, we can only have 8 in the shells, and the reason we can only have 8 is because only the S and the P blocks have outer shell electrons. The D block is 1 block in. So all we have to do is count across the top. Oh, we're already there. Oh, let's change colors. Would we? Yes. Number 1, valence electrons. Sodium would have 1. This whole column would have 2. We skip the D block. 3, 4, 5, 6, 7, and 8. The only exception to 8 would be that helium. That helium, if you count across that row, would only be 2. So helium only has 2. What did they ask for in that one? Uranium? No, it wasn't uranium in that one. All right. So that's the number of valence electrons. So it would have 1. Oops, what happened? What happened? It's trying to make me crop. I don't want to crop. How's that? 1 valence electron. Okay. It also wants to know what's paired and unpaired. Well, the easiest way to see if they're paired or unpaired is do the electron dot notation. Okay, we have 1 outer shell electrons. Why is this thing jumping all over the place? So we have 1 electron. I'm going to switch colors again. Excuse me while I do that. Say we have 1 electron. Na, right? It has 1 dot. Well, it has 1 unpaired electron. Remember when we set these up, and I'll do chlorine. I hope chlorine's not the one on the test. Okay, so I do chlorine. Now Cl, chlorine. Chlorine's right here, right? So I count across 1, 2, 3, 4, 5, 6, 7. 7 outer shell electrons. That means 1, 2, 3, 4, 5, 6, 7 dots. It doesn't matter where the dots go. The only thing that really matters is you put 1 on each side before you start pairing them up. And when we get done, we notice that we have an empty spot right here. There's no dot. That means that, oops, I covered right over it. Let's try that again. We only have 1 dot. And right there, that is the let's try that one more time. Ah! So we have, excuse me, that's making this video twice as long as it. 1 on each side. Then I start to double. Oh, now he's on the bottom. That's fine. But we still have 1 unpaired electron, right? 1 electron doesn't have a partner. That's where it can form a bond. Okay, that's a bonding site, unpaired electron. Now, we want to see what the charge is of this thing. Good thing I have 2 examples here, right? Remember, octet, everything wants to get as close to 8 as it possibly can. So if, say, sodium wants to get to 8, is it going to add 7? Or lose 1? Let me put add instead of a plus sign there. Uh-oh. I bet you I can go back. So we can either add 7. You know that's not going to be the answer, right? Or we can lose 1, right? Do it the easy way. We lose 1. Oh my gosh, we lost an electron. Are you sure? I'm positive. We're losing a negative charge. It becomes a plus 1 charge, right? We lost the negative. Are you sure? I'm positive. A positive 1 charge. So this whole column plus 1, this would lose 2. These would lose 3. I forgot to put the 3 there, huh? The 4's in the middle. Who cares? It could go either way, right? It's not going to matter on those. We're going to find out because of covalent bonds. It's not going to make a difference for us, right? So we can put plus 4, minus 4, and that's what I usually do when you guys are rookies, right? And then this would probably gain electron. Let's start from the other side. 0 here because it's already octet. This needs 1 more electron. Let's add it. This needs 2 more. Let's add it. This needs 3 more. Right, so the negative ones are gaining those negative charges. Right, so if we put an extra electron in there, you want to say you want to put a purple one in there? Okay. Right, now it has an extra negative charge, minus 1. Okay. I think that covers that. I'm going to stop talking, and you'll have to watch that in slow motion if you want to see it for real. Okay, I'm out of here. Video 2 is done.